Hello everyone, for this video we're going to talk about geometric series. Now what is our learning target for this video? I can find the sum of finite geometric sequence. So here, before we start with the discussion itself, let us have our short drill. You are supposed to determine the sum of the following geometric sequence. So first, second sequence, third, and then we have our fourth sequence. So you may pause the video for a while, and if you are done answering this, you may now resume watching the video to check your answer. For letter A, our sum is 31. For letter B, it's 480. For letter C, we have 15 and 1/2, or you can have 15.5. It's the same. Letter D, so our answer is 728. So guys, for your information, so the sum that you got a while ago in this geometric sequences, these are already called geometric series. So now let's talk about geometric series. So what do we mean by geometric series? So geometric series, it's the sum of the terms of the geometric sequence, and that is why the drill activity that we had a while ago is already the application of what we call geometric series. So you just simply get the sum of the values for each terms given in the geometric sequence. So of course, in the drill activity a while ago, I've given you only 5 or 4 or 7 terms in a particular sequence, and that would be easier on our part to do it manually, so you may use your calculators with you. But of course, what if you are tasked to find out the sum of the first 100 terms of a geometric series or geometric sequence? So you need to have the formula. So what would be the formula that we are going to use? So we have here S sub n equals a sub 1 multiplied with 1 minus r raised to n all over or divided by the difference of 1 and the common ratio. Now here, let me give you another example aside from the drill activity that we had a while ago. So we have 1, 2, 4, 8, 16, 32, 64. Doing it manually, if you're going to add using your calculators, you would have S sub 7, or the sum, is equal to 127. Now, what are we going to do is let us check if we will be getting the same answer if we are going to use the suggested formula for geometric series. Now, the given example a while ago is 1, 2, 4, 8, 16, 32, and 64. And our answer there is 127. Now, using our formula, let's see if we will be able to get the same answer. So, substituting, of course, in the formula, we would see that the first term here in our given sequence is 1. So, we substitute here 1. So, here. And next, we have our ratio. Our common ratio is, so 2 divided by 1, it's 2. 4 divided by 2, it's 2. 8 divided by 4, it's 2. So that means our ratio is 2. And at the same time, in the denominator of our formula, we have here r again. So let's change it into 2 as well. And after that, let's perform the indicated operation, of course. And that is, let us simplify what is 2 raised to 7. So let us process first all the operations in the numerator portion of our formula. So what is 2 raised to 7? That is 128. And now, we may have another step, which is, what is 1 minus 128? So that is negative 127. And then, next to that, you can now proceed with multiplying negative 127 with the value of the a sub 1, which is 1. And so, you will get negative 127. And you may also process the denominator already, which is 1 minus 2. and you will have negative 1. So simplify further, negative 127 divided by negative 1, you will have S sub 7 is equal to positive 127. And this is your final answer. As you can see, we got the same answer using the formula with the answer that we got using the manual process a while ago. Okay. Now, for our second example, find the sum of the first 6 terms of the geometric sequence negative 1, 3, negative 9, and 27. So again, we will rely on the geometric series formula that is given to us. And now, before we proceed with the formula, of course, you need to gather the necessary data that we need to substitute in the formula. What are those? We need to have our R, our A sub 1, and our N. R is negative 3. So 3 divided by negative 1, it's negative 3. Negative 9 divided by 3, it's negative 3. 27 divided by negative 9, it's negative 3. So they do have common ratio, which is negative 3. Then for our A sub 1, so the first term in the given sequence is negative 1. And lastly, for our N, we have 6. Why 6? Because you are supposed to find out the sum of the first 6 terms. Okay, so that is why your N is 6. Now, you may now proceed with substitution in the formula. Your A sub 1 is negative 1. Your R is negative 3. So, your N is 6. So, here as you can see, guys, since our values are negative values, so it's better if, so I just would like to suggest that it is better if you put parenthesis or any separator so that you will not get confused with the sign and the operation in the formula. Okay, so moving on. So let us process first the operations in the numerator portion of our formula. So let's simplify the negative 3 raised to 6. That is equivalent to 729. So here, negative 3, since the exponent is 6, so that means we are supposed to multiply negative 3, negative 3, negative 3, negative 3, negative 3, negative 3. So 6 negative 3s. And that is, we will be able to get positive value already. And that is positive 729. And so let's just have 1 minus positive 729 already. Okay, next to that, we have negative 1 minus 729, and that would be negative 728. And here, as you can see, in the denominator, I also applied the general rule that we use in subtracting integers, particularly if you do have different sign numbers. So we have positive 1 minus negative 3. So I applied the keep plus change. So I would have 1 plus positive 3. And so I get here positive 4 already. I simplified it already so that it would be easier for my next step. Okay, so negative 1 times negative 728, that is positive 728. So again, negative sign times negative sign, so that will be, your answer would be positive sign already. Okay, so now 728 divided by 4, so that will be 182. So therefore, the sum of the first 6 terms of the geometric sequence negative 1, 3, negative 9, 27, and so on is 182. If you are going to check, if you're going to do it manually, so you would have negative 1, 3, negative 9, 27. The next terms would be negative 81 and 243. If you're going to add it manually, you will have same answer, which is 182. So another proof that our formula is actually correct. Okay, so for our next problem, find the seventh partial sum of the geometric series with a sub 1 equals 3 and r equals 2. In this problem, we already have the necessary data for our formula, and now let's proceed with substitution. So I substituted here the a sub 1, which is 3, and we have our r, which is 2, and of course our n is 7, because we are going to find the sum of the first 7 terms of the given geometric sequence. Okay, and now let us simplify the values and perform the indicated operations on the numerator portion of our formula. So 2 raised to 7, that is 128. And so 1 minus 128, that is negative 127. Multiplied with 3, so I would have negative 381. And as you can see guys, in the denominator, I already simplify it. 1 minus 2, that's negative 1. And that's why you have here negative 1, negative 1, and negative 1 for the denominator already. So lastly, negative 381 divided by negative 1, we have S sub 7 is equal to 381. Okay, so next one, we have find the a sub 1 if S sub 7 is equal to 2186 and r is equal to 3. So this time, the sum is already given, but the first term of the given sequence is what we are going to find out. Okay, so we are going to rely still with our formula. Okay, so S sub n is equal to a sub 1 quantity 1 minus r raised to n all over 1 minus r. Okay, so substituting, our sum is already given, so 2186. A sub 1 is what we're looking for, and so it is retained here in the formula. Our r is 3 and our n is 7, because as you can see, it's S sub 7. Therefore, it's the sum of the first 7 terms of the given sequence. So, n is 7. Continue the process by simplifying first the 3 raised to 7. So, what is 3 raised to 7? It's 2187. And also, I simplify as well the denominator part already. 1 minus 3, I get here negative 2. Okay, moving on, I will subtract 1 and 2187, and I got here negative 2186. And since we do have here our denominator negative 2, we can divide negative 2186 by negative 2 to simplify this one. And so, that is equivalent to 1093. Okay, and then next to that, as you can see, our target is to find the value of a sub 1. And now, let us isolate the a sub 1, or else let us eliminate 1093 at the right side of our equation. So how are we going to eliminate this 1093? Or else, how are we going to isolate a sub 1? So simply, by dividing both sides by 1093, so cancel out. Therefore, we would have a sub 1 is equal to 2. And we're done. Okay, so for another problem, so you may pause the video for a while and answer the following problems. And if you are done already, you may continue. You resume watching the video to check your answer. So the final answer for number 1, so it's 21,845. And for number 2, our final answer here is 3,333. So of course, I want to provide you another problem. So it's an application of our topic geometric sequence, or geometric series, I mean. So the Jensen family plans to cut down their expenses every month. For the first month, their monthly expenses is 35,000. So therefore, we do have our first term already, which is 35,000. For the following months, then they play to cut down their expenses by 10% of the previous month. So how much will be their total expenses for 6 months? Okay, so now we are asked to find out the sum of all the total expenses of Jansen family for 6 months, given that they have the 10% cut down per month, 10% of the preceding month. Okay, so now let us go back with the formula itself. So here I substituted already. So for our first term, it's 35,000. And as you can see, my R here is not the 10% actually, but rather 0.9. And for my N, I use 6 because you are supposed to find out the sum or the total expenses for 6 months. Now, here, if you're going to think thoroughly, the Jansen family plans to cut down their expenses every month by 10%. So therefore, in the sequence, if you're going to cut down the 10% of the expenses, and that means in the sequence, the remaining amount or value would be the 90% of this 35,000, right? Okay, and so if you are going to convert 90% into decimal, that is 0.9. Okay, 90% divided by 100, that is 0.9. Okay, and of course, since we were able to substitute already here the necessary data, you may now evaluate the indicated equation, or else perform the indicated operation. And so you will have there 16,399.565 divided by 0.1. And so you will be able to get S sub 6, which is 163,995.65. Therefore, this would be the total expenses of Jansen family for 6 months, given that they do have the 10% cut down of their expenses every month. So if you're going to check your answer, you may also check in this process using manually. So let's say the first month, their monthly expense or expenses, it started with 35,000, and on the next month, on the second month, so deducting the 10%, or let's say the remaining expenses would be the 90%. So 90% of 35,000 is 31,500, and on the third month, their expense would be 28,350, and on the fourth month would be 25,515, and so on. And so if you're going to add all of this, all the expenses for the 6 months, you will arrive with the same answer, which is 163,995.65. Okay, so another additional problem. So here for letter A and for letter B, this is just a recall of the geometric sequence topic. And for letter C and D, it's the geometric series topic. So now you may pause the video for a while, and if you're done answering all of these items, you may now resume watching the video to check your answer. For letter A, our answer is A sub 1 equals 1/2. For letter B, our A sub 1 is equal to -4. Now, let's move on with geometric series. For letter C, our answer, the S sub 5 is equal to 55. And lastly, our S sub 8 is equal to -6,560. Okay, so that's it for this video. Thank you so much for watching. I'll see you on our next video lesson, and don't forget to rewatch the previous video so that you will be able to understand thoroughly all the topics about sequences and or patterns. Thank you so much for watching. See you on my next video lesson.